Hello there, welcome to the June 2019 paper 2. Here we're on question 6. In an arcane diagram, the points A, B and C represent vertices of an equilateral triangle with centre at the origin. The point A represents the complex number 6 plus 2i. So let's visualise that. It's going to be 6 across, 2 up. That there is coordinate A. And then two other points will be B and C that will make ourselves an equilateral triangle. So maybe down here and maybe one down here. Find the complex numbers B and C, giving your answers in exact form of x plus yi. So one way of doing this would be to transform 6 plus 2i into a complex number and then multiply it by, so if we're moving round the arcane diagram, then this would just be a multiplication of e to the 2 pi by 3. If we move it around again, this would also be a multiplication of e to the 2 pi by 3i. And yeah, so we could do it that way. Alternatively, I'm going to do it a very sneaky way actually. I'm going to use matrices to do this. So what I'm going to do is I'm going to go back to what the matrix transformation would be for a, what would this be? It would be a 120-degree rotation. So let's work out what that is. For the 120-degree rotation, we want to send the coordinate 1, 0 to the coordinate up here, which is going to be minus a half root 3 over 2. So that's going to be the first part of the coordinate, and then we want to send this coordinate here down to this coordinate down here. So that's going to be the second part of the coordinate, which is minus root 3 over 2 minus a half. So therefore this is going to be a matrix transformation of minus 1 over 2 root 3 over 2 times, sorry, not times, but then on the next column it's going to be minus root 3 over 2 minus a half. This here I've just calculated is the matrix transformation of a 120-degree rotation anti-clockwise. In fact, it wouldn't matter actually if you did clockwise or anti-clockwise, it would just work out the different points in a different order. So then it's going to be of the coordinate 6, 2. So I'm transforming this coordinate 6, 2, and the multiplication answer here will be my first coordinate up here. We'll call that coordinate B. So let's go ahead and do this transformation. So it's going to be multiplied along and down. So it's going to be minus 6 times a half, that's minus 3. And then down, that'll be minus root 3. And then for the next one, it's going to be root 3 over 2 times 6. That'll be 3 root 3. And then plus cross and down, so that'll be minus 1. So that'll be the next coordinate here. We'll call that coordinate B. And then we'll move on to the next coordinate. We'll do exactly the same matrix, but then we'll do it to the new pair of coordinates. And that would effectively rotate it round on again. So that's going to be to minus 3 minus root 3, 3 root 3 minus 1. Okay, let's multiply this matrix together here. Just a reminder, B is minus 3 minus root 3 and root 3 minus 1. That's just to be clear on that. So let's multiply the matrices together now. So let's multiply across and down. So it's going to be 3 over 2 plus root 3 over 2. And then multiply the next one. And then we multiply it across and down. So the next bit is going to be minus 3 times 3. Root 3 times root 3 is 3. So that'll be minus 9 over 2. And then this bit times that bit, that'll be plus root 3 over 2. Okay, let's move on to the next bit now. So it's going to be minus 3 root 3 over 2. And then that bit times that bit will be minus 3 over 2. And then across and down, it'll be minus 3 root 3 over 2. And then that bit times that bit will be plus a half. So when the top and bottom of this gets simplified, the 3 over 2 and the minus root, that'll be minus 6 over 2, so that'll be minus 3. And then that times that would be plus root 3. And then minus 3 over 2 plus a half, that would be minus 1. And then the next bit is going to be this, that, so that'll be minus 3 root 3. Okay, so there we are, that's the answer for coordinate C. So just to make it clear, the coordinate is minus 3 plus root 3, minus 1 minus 3 root 3. So there we are, that's the answer for part A. Moving on to part B now, the points D, E and F are midpoints of the sides of triangle ABC. Find the exact area of DEF. Okay, so this could be a complicated question where we find the midpoints of all three of these coordinates and then work out the areas of them. So we need to work out coordinate where D is, where E is, and where F is. But actually, if we think about this problem here, let's just rotate it around a little bit to view it better. If we've got these points A, B, and C here, and then if we work out a triangle from the midpoints, then actually it's just going to be a quarter of the total area from A, B, C, and D, because D, E, and F will all three of them be midpoints, so it'd just be this area here. So you just take a quarter of the area A, B, C, and that would be area D, E, F. And it doesn't matter if you stretch it, if it's not a perfect equilateral triangle, but given that this definitely is an equilateral triangle, this definitely must therefore be the case. So therefore it's just going to be a quarter of the area ABC. Now the area ABC is going to be, we need to work out the length of one of these lines, or in fact, is there another way of doing it maybe? Using the midpoints. If we just work out the, in fact, let's just do this. So instead, what we're going to do is we're going to divide our triangle like this. So starting from the center, we know the center is 0, 0. And we know that one of the vectors is 6 plus 2i. So if we know one of the vectors is 6 plus 2i, then this side here is going to be 40, root 40 actually. So it's 6 squared plus 2 squared, 36 plus 2 squared is 4, so that would be square root of 40. So let's write that down. So OA is equal to the square root of 36 plus 4, which is root 40. And given that the points have just rotated around the origin, all three of these distances here are going to be root 40. So it's the same for OB, and it's the same for OC. We also know that this angle here is a 120-degree angle. So if I now work out what this triangle here is, and then times it by 3, then that will give me the area of this triangle. So ABC, the triangle ABC is equal to 3 times a half AB sine C. So half root 40 times root 40 sine 120. So therefore the area of ABC is going to equal, let's do it on the calculator then, 3 divided by 2 times 40 times sine 120, and that gives me 30 root 3. So therefore the area of DEF is just going to be a quarter of this. DEF equals 30 root 3 over 4 units squared. So there we are, that's the little cheeky way of doing question B. And there we are, that's the answer for question 6, worth 9 marks in total there. Let's now move on to question 7.